Capital One is building something completely new. Capital One Cafes. Inviting places with people here to help you, not sell you. And savings and checking accounts with no fees or minimums. Because...
Hi guys, I see that commercial so often, and we're getting ready to talk about interest rates and interest, so I thought I would throw that out there. What's the deal with savings accounts and investing? I mean, that's a huge thing. There's a huge demand for investments and trying to grow your money. So we're going to kind of take a look at that. And why is it in the logarithm unit? Well, to solve some problems, we need some logarithms, and hopefully some of this stuff could be exponential growth. So without further ado, let's look at some interest. And so here we go. Interest is a interesting idea. It really boils down to just a percentage of some money. So just by having your money in a savings account, the banks will say thank you for trusting us with your money, and they will add a percent of that money, however much you have in there, back onto your total. Wow, thank you. So just don't put it under your mattress. If you have it in a bank, they're going to add some to it. Now, don't get me wrong, and we'll see this in a second, we're not going to get rich by putting $1,000 in the bank, but more money is better than not more money. So there's some different kinds of interest we're going to talk about. The first one is simple interest. Simple interest is just a one-time thing. They look at your account and say, cool, thanks for the money. Here's a percentage. And that percentage we call an interest rate, the interest rate. The actual, to find how much interest you're getting, how much more am I going to actually get to do this? We multiply the principal, how much there is to start with, times the interest rate, times how many years we're talking. Okay? That's normally the formula you would see. I find this formula over here to be more helpful, which is how much is in my account total. How much is in my account, how much do I owe, or how much do I have, is equal to how much I started with, plus that interest we just talked about. Right? Here's the interest, PRT. How much is in our account is how much we start with, plus how much they're adding on. Okay, well then in a little bit of math here, we see that these both have a P in common. We can take the P to the outside, and this is a more helpful and will look like the other versions of the interest formulas you guys are going to get. So here are all the things. Simple interest is just linear. However much you get, it is increasing by the same amount. Your account is increasing by the same amount as time passes by. It's not growing exponentially. And notice there are no exponents in this thing. So simple interest, pretty easy formula to work with, plug and chug. I have $1,000 in this account, or I'm paying someone. How much are they going to owe me back? Something like that. What is the interest rate? How long are we talking? Plug it all in there. That will be the final amount. Okay. The next kind, and probably more prevalent in today's society, would be compound interest. Compound interest is, here's the formula. I'll let you write it down as I'm talking about it. That would be growing exponentially. The bank looks at your account and says, oh, you have some money with us? Thank you. I'm going to add some to it. And then they look again, but now there's more money because they added some to it. Wow, there's even more money. So I'm going to give you even more money than that. Okay, then they compound again. Wow, there's even more money this time. I'm going to give you more money based on that. So the more money you have, the more they give you, the more they give you, the more you have. And this thing would grow exponentially. And that's why it's in the section it's in. We have this exponent here to the NT power. P is still the principal. R is still the interest rate. T is still how many years we're talking. N is this new one now. N is how many compoundings there are per year. So you'll see problems say something like compounded daily. N would then be 365. Or compounded monthly. Okay, then N would be 12. Compounded biannually. That would be twice a year. So 2. So it depends on what the problem is, or what the bank is, or whatever we're dealing with. Depends on those things. Here, let me show you real quick. I had that Capital 360, this guy, I had his bank up. It's not really his bank, he's an actor, right? But here's Capital One. And if you go down and look, it talks about compounding and crediting. Interest on your account will be compounded and credited on a monthly basis. There's also some other things. It's confusing, right? We kind of got to be financially illiterate. Accrual of interest on deposit, almost make it seem like, oh no, this one, balance computation method. We use a daily balance method to calculate the interest on your account. So it almost sounds like they use daily there. But, I mean, banks are pretty sneaky. They'll use different things. You'll see APY sometimes touted, or you'll see APR as what they advertise. These are different things, but at the heart of it, we're still talking interest. Okay, so there's one other one I want to talk about, and you can tell I made these when Christmas was around because I had this silver, write your name on the presents, who they're from. This glows pretty good, but hopefully you can see it. Now, as we make N huge, remember N was how many times we're doing it a year? Well, what if instead of daily, we do it twice a day? What if we do it once an hour? What if we do it, and as we take this thing called a limit, which is a very pre-calculus, calculus type of idea, this is where E came about. We take a limit as we let N get huge. If N gets humongous, the inside of this thing turns into that 2.75, whatever that number was, Euler's number. And so we get this thing called continuous compound interest. Continuous compound interest is PERT, P times E to the RT power. Sometimes I think of it as that ticker that goes down near New Year's, where it's just a countdown and it's continually moving. That's your account. With continuous compound interest, your account is just continuously increasing. Now, it's not increasing by a lot. Again, you're not going to get rich by doing this, but it is just increasing all the time. And the more compoundings you get, the more money you have in the account. The more money you have in your account, the more money they're going to have to compound interest with. So this one will give us the biggest yield, will give us the most amount of money. So how much is in your account, the principal, Euler's number, the interest rate written as a decimal. Remember, they'll probably say 1.5%, but then we would put that as 0.015 in our formula. And T is how long, how many years we're talking. Okay. So let's try one example problem with this, and then we can do some practice. So you just found a bag of money. Hooray for you. $2,000. We are going to put that money in a Capital One 360 account, and this was last year or the year before. They touted a 1.7% APY, average percent yield. With a little bit of digging, I figured out that the interest rate was actually 1.6869, so it's a little bit different. I want to know how much is going to be in the account after 16 years. Your first question to me, if you are picking up what I'm laying down, is how are they compounding the interest? Well, I'm glad you asked, okay? I want you to do it first monthly. I think that's kind of what we said in there. So we're going to try it monthly. So P is the 2,000. The interest rate written as a decimal. For 16 years, we're going to put this $2,000 in there and see how it grows. And they're going to compound the interest once a month, monthly. So we can put all this stuff in our formula. From here, it's just a plug and chug, really. $2,000, 1 plus R over N to the NT power. Make sure you're plugging your calculator correct. And at the end of 16 years, you would have $2,619.18. So again, you're not getting rich by doing this, but that's $600 more than you had before. And then there's things when we really get into the math and economics of inflation rate after 16 years, how much is that really worth? It's not worth the same as it is now, but we're being hypothetical here. Let's try this again. I want to do the exact same problem, the $2,000 with the same interest rate for 16 years, if these stipulations were met. What if it was simple interest? Practice the simple interest formula. What if it was compounded semi-annually? What if it was compounded continuously? And then finally, the last problem I want you to do is a little example. How long would it take to double your $2,000 in the real, and this one up here, Capital One 360 account? Okay, hit pause, try each of these, come back, we'll look at our answers and see what you're doing right, what you're doing wrong, and then we're almost done. Got about 1 more minute. Okay, we're back. I'm back. First one, simple interest. We have A equals 1 plus RT. Plug it all in. After 16 years, we would have $2,539.81. Not that much after 16 years. The second one, if it was compounded biannually, N would be 2. We use our compound interest formula, plug in the numbers where they go, and again, more than it was with simple, because they're looking at it, there's more money in it now, so when they give you the interest, they're going to give you more. Then the next one, continuous. It's continuous now, barely more than the semi-annually, right? 2,616, 2,619. But again, more is more. And if you have more principal, more money in these things, then this difference would be bigger. And then finally the last one. I just put the answer here. Takes 41.1 years to double your money. I want to take a look at that one. I can show you guys where it came from. So if we have how much is in my account is equal to the principal, 1 plus r over n to the nt power, we want to know when this is going to be doubled what this is. Right? The question was when there's twice as much in your account. So A would be double the amount of P. So it would be like 2P. 2P equals P, all that stuff to the nt power. From here I would divide by P. I could get 2 equals that whole thing to the nt power. I would take the log of both sides, log of this, log of this. That would make the nt come out front. Log 2 equals nt log of that whole thing. And then finally, to solve for t, I would divide by n and divide by log of that thing. So look, log 2 divided by n and the log of that whole thing. We jam it in our calculator and we're not getting rich. But again, they're giving us more money than we had before just to have our account in there. Okay. That's it. That's our interest stuff. Try the review. There may be some practice problems as well. Be checking out the what's out there sheet, and we are moving on.